Now question is, a box contains 10 red and 20 blue marbles. 10 red, 20 blue and 30 green marbles. 30 green marbles. So total is 60. Now experiment is, 5 marbles are drawn from the box. From this box, 5 marbles are drawn. What is the probability that all will be blue? At least one will be green. So to find the probability of this event and this event, first of all, as per given experiment, that select 5 marbles, draw 5 marbles from this box. So first of all, we find total number of possible outcomes. Total number of selections of 5 marbles from given 60 marbles is n equal to, from this 60 select any 5 marbles. So that is 60C5. So whenever we select any 5 marbles from this box, then total number of different selections is 60C5. Now we are coming on event. Now we want probability of event that all will be blue. So let me suppose A is the event that all 5 marbles will be blue. So if all 5 marbles will be blue, then it comes from this 20 marbles. To have all 5 blue marbles, we have to select all from this 20. So total number of such selections, is, let me say R. So R is equal to, take 5 marbles from 20. So that is 20C5. So therefore, probability of event A that all 5 marbles will be blue, it is equal to R by N, that is 20C5 upon 60C5. So therefore, probability that all 5 marbles will be blue is 20C5 upon 60C5. This can be calculated using calculator. We can calculate it. Then second event is, now second event, we want probability that at least one will be green. So let me suppose B is the event that all B is the event that at least one will be green. At least one will be green. So if B is event that at least one will be green, that means not all will be from red and blue. At least one green means if you take one from this side, then take 4 from red and blue. If you take 2 from green, then take 3 from red and blue. If you take 3 from green, then take 2 from other colors. Take 4, then here 1. Take all 5 green, then no red or blue. So this number should be at least 1. But this is not allowed. All 5 from this red and blue and here 0. This is not allowed. We don't want all 5 from red and blue. According to this instruction, at least one will be green. So this is not allowed. So we want complement event of this action. That means, so this is complement of B. So B dash means, B dash is the event that no green marbles selection doesn't contain green marble. That means event that no green marble is selected. At least one green, its a complement is no green. So such selection, number of such selections that means no green, 0 green, it is equal to, it should be from this 30 marbles. So take all 5 from 30. So 30 C5. Here I am putting reason 10 red plus 20 blue. So take 5 from this 30 marbles. So 30 C5. So this 30 is taken here in calculation. So here I am putting in detail, that's 10 plus 20 C5, that is 30 C5. So this is the number of selection that no green marble is selected. But we want at least one green, that means we want probability of B. So required probability is equal to probability of B, and probability of B is 1 minus probability of B dash. So probability of B dash is, so here see in B dash number of outcomes are, again I am putting here slightly in detail. If we say this number is R, then probability of B dash is R upon N, that is 30 C5 upon 60 C5. So that is probability that no green marble is selected. So probability that green marble is selected, so probability that at least one marble is green is, that is P of B, and P of B is P1 minus P of B dash, that is 1 minus 30 C5 upon 60 C5. So this is required probability. Now next question. 4 cards are drawn from a well shuffled deck of 52 cards. What is the probability of obtaining 3 diamonds and 1 spade? 4 cards are drawn from a well shuffled deck of 52 cards. So experiment is select 4 cards. So first of all, we are selecting 4 cards from 52. So total number of selections of 4 cards from deck of 52 cards is n equal to, from 52 select 4, 52 see 4. Now we are asked probability of event of getting 3 diamond and 1 spade. Now in 52 cards there are 13 diamonds and spade, that is 13 spade. So total this deck of 52 cards contain 13 diamond, 13 spade. So we need 3 diamond and 1 spade. So from 13 we will select 3, and from this 13 spade we will select 1 spade. So here from 13 we will select 3 cards, here we will select 1 card. So that will be total 4 cards in required event. So now from 13 diamond selecting 3 cards, and from 13 spades selecting 1 card. Total number of selection of total number of such selections of 4 cards is, let me say R is equal to, from 13 select 3, 13 C3, and means into, from 13 select 1. So from diamond 3 diamond is selected, from spades 1 spade is selected. So required probability is R upon n. So that is, required probability is 13C3 into 13C1, 13C3 into 13C1 upon 52C4. So that is 13 into 13C3 upon 52C4. So that is required probability. Now in this question, a die has 2 faces, each with number 1, 3 faces each with number 2, and 1 face with number 3. If die is rolled once, determine probability of getting 2, probability of 1 or 3, probability of not 3. So here in this question, number 1, this is on 2 faces. Number 1 is on 2 faces. Number 2 is on 3 faces. And number 3 on 1 face. Number 3 on 1 face. So total there are 6 faces on a die. Now probability of, so from this information here it is clear that probability of getting 2, probability of getting number 2, that is probability of getting number 2, it is 3 by 6. So that is 1 by 2. Probability of getting 1, let me put value for 1. First of all we are putting for 1, we are putting in sequence, probability of getting 1, probability of getting 2, probability of getting 3. So probability of getting 1 is 2 by 6, that is 1 by 3. Probability of getting 2 is 3 by 6, that is 1 by 2. And probability of getting 3, 3 is on 1 face, so it is 1 by 6. So here probability of 2, that here it is clear that probability of getting 2 is 1 by 2. Now probability of 1 or 3, probability of 1 or 3, getting 1 and getting 3 at the same time, these two results are not possible because 1 is on 2 faces and this 3 is on 1 face. This is different face. At the same time we can't get 2 faces on upper side. When we toss a die, at the same time 2 faces as an outcome is not possible. We can get observation only 1 face, not 2 faces. So getting 1 and getting 3, so both results at a time is not possible. So these are mutually exclusive events. So mutually exclusive events, so let me put that statement. Now getting 1 and getting 3 or getting any 2 number, these events are mutually exclusive at the same time, both do not occur together. So probability of 1 or 3, probability of event A or B is probability of event A plus probability of event B. When 2 events are mutually exclusive, A and B are mutually exclusive, probability of A union B is probability of probability of A plus probability of B. Now probability of 1 is 1 by 3 and probability of 3 is 1 by 6. So this is 2 by 6 plus 1 by 6, that is 3 by 6, so it is 1 by 2. Then probability of not 3, probability of not 3, that is 1 minus probability of 3. So 1 minus 1 by 6. So it is 5 by 6. In a certain lottery, 10,000 tickets are sold and 10 equal prizes are awarded. What is the probability of not getting a prize? If you buy 1 ticket, 2 tickets or 10 tickets. say here total number of tickets. Total number of tickets is 10,000. In this 10,000 tickets, there are 10 equal prizes are awarded. That means out of 10,000 there are only 10 tickets which are prize bearing tickets. So number of prize bearing tickets are only 10. So therefore number of non-prize bearing ticket is 10,000 minus 10, that is 9,990. 10,000 minus 10, so 9,990 tickets are non-prize bearing. Now we are asked probability of not getting a prize. If a ticket is not getting prize, that means it should be purchased from non-prize bearing tickets. It should be from this group. So here we answer one by one. If one ticket is not getting a prize, so let A be the event. A be the event that one ticket is not getting a prize. If you buy a ticket which is not getting a prize, so one ticket is not getting a prize. So probability of this event is equal to total number of outcomes in event A upon total number of outcomes in sample space. So here if one ticket is not getting a prize, then in this event, in how many ways this ticket can be purchased? So there are such 9,990 tickets. So take one ticket from 9,990. So 9,990 C1. From this select any one. It will be non-prize bearing ticket. Divide by 10,000 C1. Select one from these 10,000 tickets. If one ticket is selected, so total number of selection of one ticket is 10,000 C1 and total number of selection of one ticket which is non-prize bearing is 9,990. So this is required probability. Second question is two tickets are non-prize bearing. So let me say event B. B is the event that two tickets are non-prize bearing tickets. Here one ticket is non-prize bearing ticket. Putting proper words. So if two tickets are non-prize bearing tickets, if we buy two tickets, then probability of this event is probability that no ticket is getting prize, that is select two tickets from 9,990 tickets. So 9,990 C2 upon total number of selection of two tickets from these all tickets 10,000. So 10,000 C2. C, if we purchase 10 tickets, so let me take event C. C is the event that 10 tickets are non-price bearing tickets. If all tickets are non-price bearing ticket, then no on any ticket there will be price. So probability of this event is, so probability of C is, so here we are selecting 10 tickets and all are non-price bearing. So 10 tickets select from this number. So 9,990 C10 upon total number of selection of 10 tickets. So total number of selection of 10 tickets, that is from 10,000 C10. So that is required probability. Out of 100 students, 2 sections of 40 and 60 are formed. If you and your friend are among the 100 students, what is the probability that you both enter in the same section or you both enter in the different section? So see here the random experiment is 100 students, out of 100 students 2 sections of 40 and 60 are formed. So total number of ways of forming 2 sections of 40 and 60 students from given 100 students is n equal to, from 100 students select any 40 students. From 100 select any 40. Now out of 100 40 are selected. Now how many are left? Out of 100 40 are selected, so 60 are left. So remaining 60, select all 60. So this is first division, first section. The left group of 60 students will be second section, automatically it will be formed. This value is 1, so this is 100 into 100C40 into 1, so it is 100C40. This is value of n. Now let us discuss case 1. We find number of ways in which both enter the same section, you and your friend. Both enter in the same section. So in this case, to enter 2 students, 2 particular students, let me say students are A and B. To enter 2 particular students in the same section, we want to enter 2 particular students or to allow 2 particular students in the same section. To allow 2 particular students in the same section, first of all, in the procedure, you keep them standing inside. So keeping them inside. Keeping these 2 students inside, 98 students are left. 98 students are left. So what we do? From 98, first of all, from these 98 students, we are forming, now we form 2 sections. 2 sections of 40 and 60 students. Now these 2 particular students which are standing inside, we want to allow both students in the same section. So from remaining 98, first of all, to form a group of 40 students, select 38. So number of ways of forming section of 40 students equal to, see, first of all we are forming 40 students, number of ways of forming section of 40 students in which these particular students are allowing A and B, or including A and B both, including A and B both. So number of ways of forming section of 40 students including A and B both equal to, see, procedure is from 98 students select 38 students. From 98, 2 students are already standing inside. So from 98 students, first of all select 38 students. Then 2 students are already inside, select them, 2C2. So they are included. So out of 98, select 38. Then from 2 particular students, select both. So this number of selection, this product gives number of ways of forming 40 students in which A and B are included. And now out of 98, 38 are selected. These 2 were standing inside, both are taken. Now still how many are left? See, out of 100, 40 are selected. Now 60 are left. See, from this 98, 38 are selected, still 60 are there. So from 60, select 60. So in this group, A and B are included. Here A and B are included. In section of 40 group. Now similarly, number of ways of forming section of 60 students, section of 60 students including A and B both equal to, now we want both particular students in section of 60 students. So total number of ways of forming such section including A and B is, so from 98, see already 2 students are standing inside whom we want to include in 60. So from 98 select 58. From these 98 students select 58. 2 are standing inside. Now call them to come in this section. So those 2 particular students, select both students, 2C2. 2 students from 2, select both. So this is section of 60 students. So here A and B are included. A and B are included in section of 60 students. So this is section of 60 students, and now 40 are left. See, 100 out of 100, 60 are taken, or from 98, 58 are taken. So still here 40 are left. So from remaining 40, select or 40. So this is section of 40 students. This is section of 60 students. This is section of 40 students. Therefore, total number of forming sections, in which such that both enter the same section. So total number of forming sections, total number of forming 2 sections such that both A and B enter in the same section is equal to, it is equal to R is, say this is total number of ways of forming 40 student section including A and B, and here in 60 A and B are included. So this number plus this number. So this is 98C38 into 2C2 into 60C60 plus, putting this properly, R is equal to 98C38 into 2C2 into 60C60 plus, this is 98C58 into 2C2 into 40C40. So this is equal to 98C38. This is 1. This is 1 plus 98C58 into, this is 1. This is 1 because NCN is 1. So required probability is, therefore required probability is equal to R upon N. So that is 98C 38 plus 98C 58 upon 100C 40. So continuing from this step, this is equal to NCR is n factorial upon r factorial into n minus r factorial into plus, next sign is plus. Again NCR is n factorial upon r factorial into n minus r factorial. So this is equal to upon this is missed 100C 40. So 100 factorial upon 40 factorial into 100 minus 40 factorial. So this is equal to, so see here it is 98 factorial upon 38 factorial into 98 minus 38, that is 60 factorial plus 98 factorial upon 58 factorial into, this is 40 factorial upon 100 factorial upon 40 factorial into 60 factorial. This is equal to, now see here this is 98 factorial plus here 98 factorial. This 100 factorial can be expressed as 100 into 99 into 98 factorial. So this 98 factorial can be cancelled. Now look here, this is 38 40 40. So 38 factorial keep as it is, 60 this is 58. So 38 factorial keep as it is, then 60 can be expressed as 60 into 59 into 58 factorial. This 58 factorial keep as it is, 40 into 39 into 38 factorial. Similarly here 40 factorial is 40 into 39 into 38 factorial. 60 factorial is 60 into 59 into 58 factorial. So these factorial terms now we are taking common, 38 factorial, 58 factorial, 58 factorial, 38 factorial. See, whatever is rounded part, that will be common. So this is equal to 98 factorial upon 38 factorial into 58 factorial common into bracket 1 upon 60 into 59 plus 1 upon 40 into 39 upon here 100 into 99 into 98 factorial upon 40 into 39 into 38 factorial into 60 into 59 into 58 factorial. So this will be cancelled. Factorial terms will be cancelled. So this is equal to now here 1 upon 60 into 59 divided by 100 into 99 upon 40 into 39 into 60 into 59 dividing individually plus 1 upon 40 into 39 upon, this is 100 into 99 upon 40 into 39 into 60 into 59. So here 60, 59, 60, 59 cancel. Here 40, 40, 39, 39 cancel. So this is 40 into 39 plus 60 into 59 upon 100 into 99. So that is, now here 40 into 39 plus 60 into 59. Here 10 is common. Simplifying this, 39 into 40, or taking here 10, still we can divide by 10. So 4 into 39 plus 6 into 59 upon 10 into 99. So this is equal to 39 into 4, that is 40 into 4, 160, 160 minus 4, 156. This is 360 minus 6, 354 upon 10 into 99. So this will be 350 plus 150, 510. So this is 510 upon 10 into 99. This 0 is cancelled, 17 by 33. So that is the probability that both students enter in the same section. Now second case, if both enter the different section, case 2. If two particular students enter in the different section, so once again keep them standing inside to allow both students in the different section again keep them standing, both students A and B, again keep them, that is A and B, standing inside. We will allow them in different section. So again 98 students are left. Now we discuss cases. To allow both in different section, first of all we will allow A in section of 40 students, B in section of 60 students. Then next time B will be in section of 40 students, A will be in section of 60 students. So to perform this procedure, total number of such selections, total number of such formation of both sections, total number of such formation of both sections is equal to, R is equal to total number of such formation of both sections is R is equal to, say two students are standing inside, A and B both are standing inside, 98 students are there. So from 98 students, select 39 students. From 98 students, select 39 students. Then from those two students, A and B, from two students, select any one. So this is section of 40 students, and means into. Now out of 98, 39 are taken. Out of 98, 39 are taken. Now how many are left? 59 are left. So from 59 students, from these 98, 39 are taken. Now 39 taken, so how many are left? 59. So 59, select all 59. 59, see, 59. Then in this 59 students, say here out of 2, 1 was selected, now still 1 is left from those A and B. So select 1C1. So this is group of 60 students. So in section A, any one from A and B, and remaining student in section of 60 students. So both students in different section. So this is equal to 98C 39 into 2C1. 2C1 is 2. So 2 into 98C 39 into 59C 59 is 1. 59C 59 is 1. 1C1 is 1. This is 1. Rewriting again, 98C 39 into 1 into 2 into 1 into 1. So 2 into 98C 39. So required probability is R upon N. So 2 into 98C 39 upon N was 100C 40. In the beginning we calculated this 100C 40. So this is equal to 2 into, now NCR is N factorial upon R factorial into N minus R factorial upon 100 factorial upon 40 factorial into 100 minus 40 factorial. So that is 2 into 98 factorial upon 39 factorial into, this difference is 59 factorial upon 100 factorial upon 40 factorial into, this is 60 factorial. So this is 2 into 98 factorial upon 39 factorial into 59 factorial upon, now see 100 factorial we keep as 100 into 99 into 98 factorial. 40 factorial is 40 into 39 factorial. 60 factorial is 60 into 59 factorial. So this 39 factorial, 59 factorial cancel. 98 factorial is cancel. So this is 2 into this 40 into 60 comes in numerator. 40 into 60 upon 100 into 99. 0, 0, 0, 0 is cancelled. Here 2 into 3, 6. 33 into 3, 99. So 16 upon 33. 3. This is required probability. See, 3 letters are dictated to 3 persons and an envelope is addressed to each of them. The letters are inserted into the envelopes at random so that each envelope contains exactly one letter. Find the probability that at least one letter is in its proper envelope. At least one letter is in its proper envelope. See, there are 3 envelopes. Suppose these are envelopes and there are 3 letters. This is letter 1, letter 2, letter 3. Now this letter can be placed by 3 ways. This can be inserted in this envelope, or it can be inserted in this envelope, or this can be inserted in this envelope. So first letter can be inserted by 3 ways. This can be inserted by 3 ways. Suppose this is inserted in this envelope. Now we are not allowed to put second letter in the same envelope. In each envelope only one letter. Now 2 envelopes are empty. So this envelope can be inserted in this letter can be inserted in this envelope or in this envelope. So this can be inserted by 2 ways. Suppose this is kept in this envelope. Now 1 letter and 1 envelope is left. So this is by only 1 way in this envelope. So total number of ways of inserting 3 envelopes, 3 letters in 3 envelopes is n equal to 3 into 2 into 1. That is, there are 6 ways. 3 into 2 into 1. Now we find number of ways in which at least one letter is in proper envelope. So first case, if one letter is inserted in its proper envelope, then it can be done by now one envelope in its proper letter. So see, once again by same picture we are discussing. These are 3 envelopes. These are 3 letters. Letter 1, letter 2, letter 3. Suppose this is for this envelope. This letter is for this envelope and this letter is for this envelope. These are 3 envelopes. Addresses are written. These 3 letters, L1 is for E1, L2 is for E2. Now, if one letter is inserted in its proper envelope, then select any one letter. Select any one, keep in its proper envelope. Suppose if you select L1, put L1 in E1, then don't put L2 in E2, L3 in E3, but cross them. Put L2 in E3 and L3 in E2. So in that case, this will be in proper envelope. So L1 in proper envelope, or take L2 put L2 in its proper envelope, and these two letters cross them in this envelope. So L1 in E3, L3 in E1. Don't put them in proper envelope. Put only L2 in this proper envelope. Or third case is put L3 in E3. Don't put these two in proper envelope. So this can be done by three ways. Means select any one letter from these three letters. Put them in proper envelope. So this can be done by 3C1 ways. That is three ways. Select any one letter proper, put in its proper envelope. That is 3C1. Now, if two letters are inserted in its proper envelopes, then by how many ways this can be done? See, once again, if two letters in proper envelope, L1, L2, L3. If we put two letters in proper envelope, suppose L1 put in E1, L2 put in E2. So this is correct. So what will happen? Automatically L3 will be in E3 in proper envelope. So when you put two letters in proper envelope, that means all three will be in proper envelopes. So this can be done by only one way. Put any two in its proper envelope, third will be automatically in its proper envelope. So it can be done by only one way. And same case is for three letters. So this is the same way for three letters. So here, if two letters are inserted in its proper envelope, then all three will be in their proper envelopes. So therefore total number of ways of inserting at least one letter in its proper envelope is R equal to 3 plus 1, that is 4. So required probability is R upon n, that is 4 by 6. N was 6, so that is 2 by 3. Now question is, if 4-digit numbers greater than 5000 are randomly formed from these digits 0, 1, 3, 5 and 7, what is the probability of forming a number which is divisible by 5 when the digits are repeated and the repetition of digit is not allowed? Here there are two sub questions. The first case is we perform experiment when digits are repeated. So case 1, with repetition of digits. With repetition of digits, which digits are given? 0, 1, 3 and 7. These are given digits. We want number greater than 5000. Numbers greater than 5000 and 4-digit numbers. 4-digit numbers greater than 5000. 4-digit numbers greater than 5000. How many such numbers can be obtained? So this is case 1 with repetition. How many 4-digit numbers greater than 5000 can be formed? So 4-digit number. So suppose 1, 2, 3, 4. This is more than 5000. So this place can be filled up by, here one number still is missed, 1, 3, 5, 7. 5 and 7. So this place can be filled up by 5 or 7. By 5 or 7. So this by 2 ways. Any one from 5 and 7 can be taken here. Then this number will be more than 5000. And now repetition is allowed. So if you put here 5, then 5 can be used again. If you put 7, then 7 is allowed again. So because it is a repetition, each place can be filled up by, with repetition of 5 or 7, 1, 2, 3, 4, 5. So each place can be filled up by 5 ways. 5 ways. This by 5 ways. Here only 2 digits, 5 or 7, because we want more than 5000. And here any digit can be repeated. So that will be case with repetition. So total number of such numbers, equal to 2 into 5 into 5 into 5, that is 250. There are such 250 numbers. But in this 250 number, say if you put here 5, if you put 5 and if you repeat 0, then this 250 numbers includes 5000. But we want a number greater than 5000. So from this 250 we have to exclude these numbers. So we are excluding these numbers. Therefore, but 5000 is included in 250 numbers. Therefore, total numbers which are greater than 5000 are n equal to 250 minus 1, that is 249. There are 249 numbers in which digits are repeated, numbers are 4-digit numbers, and all are more than 5000. So this is a total number of outcomes when we perform this experiment of formation of 4-digit numbers, which are all numbers more than 5000 and with repetition. Now we are coming on event. What is the probability of forming a number divisible by 5? Now how many numbers are divisible by 5? That we find out in this group. So numbers divisible by 5. In this case, we find numbers divisible by 5. So say, when we want to find numbers divisible by 5, then this place, unit place, can be filled up by only 2 digits. 0 or 5. If here you keep 0 or 5, then this is divisible by 5. So this is by two ways. If a unit place is 0 or 5, then that is divisible by 5. Now here repetition is allowed. So this place can be filled up by total 5 digits. 5 ways, this is by 5 ways. Any digits can be taken in these places, but here 0 cannot be taken. So except 0, this can be filled up by 4 ways. This is by 4 ways, except 0. So total number of such numbers, see one more point. Sorry, I did mistake. This place cannot be filled up by 4 ways because we want numbers which are more than 5000. We are thinking about numbers from this group. So because we want more than 5000 here, only 5 and 7 are allowed. So this is by 2 ways. 2 ways. Only 5 or 7 is allowed here. So by 2 ways. So total number of such numbers are equal to 2 into 5 into 5 into 2. That is 100. But see, once again, look here. If you put here 5 and if you keep here 0, 0, 0, then that is not more than 5000. But so don't say this number as R. R symbol we use for required number. So total such numbers 100, but 5000 is included in 100 numbers, which is not more than 5000. So we have to exclude 5000. So required numbers, therefore required numbers R is equal to 100 minus 1, that is 99. So required probability, therefore probability that number is 4-digit number greater than 5000, which is divisible by 5, is probability of this event is R upon n, that is 99 by 249. So this is probability of first event. Now case 2. If repetition is not allowed, repetition of digit is not allowed, that means without repetition, digits are 0, 1, 3, 5 and 7, and we want numbers, 4-digit numbers which are greater than 5000. So such numbers are 1, 2, 3, 4. This place can be filled up by 5 or 7. To have number more than 5000, this can be filled up by 2 ways. Any one from 5 and 7 is taken. Now how many are left? So out of 5 digits, 4 digits are left. So this place can be filled up by 4 ways. Then 3 digits are left. This can be by 3 ways, and then this can be by 2 ways. So total number of such numbers, is 2 into 4 into 3 into 2. So there are such 48 numbers. Now see here, this is without repetition. So in this case 5000 is not included. Now we are coming on event. Now we find numbers divisible by 5. Numbers divisible by 5. So say when 4 digit number divisible by 5, and because here 0 and 5 both digits are given, in unit place if you put 0, if unit place is 0, then remaining 4 digits we can use in this 3 places. So if 0 is at unit place, then this place can be filled up by remaining 4 digits. So 4 ways, then 3 ways, then 2 ways. This is fixed. 1 way. So numbers in which unit place 0 is 4 into 3 into 2. Therefore, numbers having unit place 0 is 4 into 3 into 2 into 1. There are 24 numbers. But see one more point. Again I am doing mistake. We are discussing for those numbers which are more than 5000. So this place cannot be filled up by 4 ways. Here, first of all, fixed here 0. Say these digits are here 0, 1, 3, 5, 7. 0, 1, 3, 5, 7. 0 is taken. So now we will not use 0. Now here we can put either 5 or 7. So this by 2 ways. 5 or 7. So 2 ways. Suppose we have taken there 7. So how many are left? 3 digits are left. So this by 3 ways. This by 2 ways. So total number of such numbers is 2 into 3 into 2 into 1. So there are such 12 numbers. So here there are 12 numbers having unit place 0. Now second case, 1, 2, 3, 4. Now if I keep here 5, see, if unit place is 5, then it is also divisible by 5. We are using this digits 0, 1, 3, 5, 7. Now if unit place is 5, then this is also divisible by 5. Here we are doing without repetition and more than 5000. So keep this point in mind. Now here 5 is taken. So 5 is fixed. This is fixed. That is 1 way. Here, because 5 is taken, we can't put here 5. So only 1 digit is left. 7. So 7 is fixed. Because we want a number more than 5000. So here 5 or 7 is allowed. But 5 is used in unit place. So we can't repeat 5. So for this place only 1 digit is left. That is fixed. 1 way. 7 is used. Now 3 digits are left. So this is by 2 ways. 3 ways. Sorry, this is by 3 3 ways, and this is by 2 ways, 1 by 1. So total number of such numbers, therefore numbers having unit place 5 is 1 into 3 into 2 into 1, that is 6. So total required outcomes, therefore total required outcomes are is equal to 12 plus 6, that is 18. So in second case, required probability is R upon n, that is 18 by 48. This was n. So 18 by 48. So 9, 3, 6 are 18, 8, 6 are 48. So 3 by 8.